All right, let's go ahead and try these two together. And then I'll give you guys lots of time to practice, okay? So here we go. It's nice on this Delta Math Link is they're going to give you the image of what's happening. The AP exam will not always give you an image of what's going on. All right, so obviously when we get into next week and then after we come back from spring break, we'll get ready for the major summatives on this. I'll show you guys how the AP exam is going to do this without giving you the figure. Okay, makes it a little tougher. Okay, so the first thing I want to do is we're trying to find this area of region R. Get my marker here. Come on. Oh. Here we go. There we go. Trying to find the area of region R. All right, and I want you to write down. Then we're going to find the integral. All right, the integral. And you want to first look at farthest left to farthest right. So what is the farthest left in terms of the x-axis? -3. And then what is the farthest right in terms of the x-axis? +3. Okay, and remember when you're doing this, we're doing the top function minus the bottom function. So what is the top function? So it is this line. You can see this line here? That's the top function. All right, so it's actually not at y equals 0. This is at y equals 2. Yes. Admissions. Excellent. You have been admitted. All right, welcome. What is the bottom function? Is it not this function here, right? The parabola? You okay? All right, so I'm going to write down the top function, which is 2, minus the bottom function, which is x squared minus 7. Now, technically, if you want to get the notation right, you need to put dx after that. All right, so we're going to take the integral or antiderivative of this, and that will give us the area between these two functions. Okay? Why do you need to? Oh, man, there's a lot more going on there. The easy answer is because that's what it's asking us to do. But in terms of your life, you may not ever have to do this. It is forever. Okay, so I'm going to do some simplifying real quick. Make sure you're writing small. I should have clarified. Make sure you're writing small. I'm going to distribute this negative, this subtraction. So when I do the opposite of x squared, I'm going to write negative x squared. You good, David? Okay. What is 2 minus -7? It's 9. Right? 2 minus -7 is really 2 plus 7, which is 9. So this is what I'm going to be doing in terms of my calculus. I'm going to do the antiderivative. Okay? So how did I get that? I did, like, there's no x squared term, right? So no x squared term minus x squared is negative x squared. And 2 minus a -7 is 9. I'm just cleaning it up before I do the antiderivative. Okay? So let's go backwards, right? Antiderivative of negative x squared is going to be negative 1/3 x cubed, right? Because I need to add 1 to the power to get x cubed, then do the reciprocal. Right? I throw that negative because we do have a negative in front. I know, high key, you got to figure this out. Okay? And then what's the antiderivative of 9? 9x. All right? And I'm evaluating this at 3 and -3. You okay, Alan? Yeah. All right. So I'm going to do f of 3 minus f of -3. Okay. Remember, this is the fundamental theorem of calculus part 2. All right, here we go. So I'm going to do -1/3 times 3 cubed plus 9 times 3. Remember, that's just one piece of it, right? That's just the first piece. Then I have to do minus negative 1/3 times negative 3 cubed plus 9 times negative 3. If there's a question, let me know. Ask, right? This is, some of you haven't done calculus in a week, so you may have some questions. Not necessarily a question, but thank you. Thank you for that. Okay, so let's go ahead and do our math here. What is 3 cubed? 27. You're good. What's 1/3 of 27? I'm going forward. You're going to miss it, right? What's 1/3 of 27? So this is going to be negative 9. All right, plus 27 minus, what's negative 3 cubed? We just did this. What's 1/3 of that? A negative times a negative is going to be positive 9, and then plus negative 27. What's negative 9 plus 27? 18. Minus, what's 9 plus negative 27? I heard Alan say negative 18. When you subtract a negative, that's the same as adding a positive. So your answer for the area under the curve is 36 Brussels sprouts.
I don't know about we, but
Okay. Any questions about number 1? Any questions on? That's it. That's number 1. It is very similar to the stuff we've been doing. It will be much harder tomorrow, yes. The only difference between what we have been doing, what we're doing now, is you've got to make this based on the figure, right? So what we have been doing last unit was I have been giving you like this, and you had to do it. So the new step is to find that area between two curves. It's the integral from the top one minus the bottom one. All right, so the top one minus the bottom one. That's how you find the area between two curves. This 2? No. This 2. Yeah. 2 minus a negative 7 is 2 plus 7, which is 9. I clean this up with simplifying first before I do the antiderivative. Because I don't want to do the antiderivative of 2 constants, because then you're not dumb, you're just asking a question. Then I would have 2x and 7x, so you're going to get 9x eventually. Okay? All right, let's do number 2. We've got a line, another line. This time this line has slope, okay, as opposed to the last line had 0 slope. And we've got another parabola. All right, so I'm going to do, this is again region R. The integral, let's start with the far left. What is my far left limit of integration going to be? Negative 1. And then far right, where are they intersecting? Positive 2. So that's the area that I care about between those x values. What is my top function? What function is on top? The line. So that's going to be 3x minus 1 minus which function is on the bottom? The quadratic, which is 3x squared minus 7. Again, technically, you would need to put dx there. So that's the setup, Valeria. Now I'm going to do some algebra simplifying, right, because I have subtraction of some like terms here, to make it look a little nicer before I do the calculus. Yes. So it's always the top one, whatever's on top, minus the one on bottom. So don't worry about f and g, right? As long as it's top minus bottom, you should be good.
The g of x is a linear function?
In this case, g of x is linear. So yes, in this case, I would have done g of x minus f of x.
So in cases where it's not linear, what would it be?
It's just whatever is on the top goes first. Wavy. You mean like a trig function?
Like if it was wavy, like
just
like curved.
Okay. Can we finish this? I'll show you an example. Okay, great. All right. Let's clean this up. Do I have another like term with this 3x squared? I don't know, right? So it's like nothing minus 3x squared. What's nothing minus 3x squared? Negative 3x squared. Okay? Do I have a like term with 3x? Do I have a like term with 3x anywhere here? No, there's no other linear term, so I'm just going to write plus 3x. Remember, what I'm doing right now is algebra, okay? And then what's negative 1 minus negative 7? It is positive 6. Again, right? Nothing about that was calculated. Everybody okay with that simplifying? Okay. Good? All right. Now I'm going to do the antiderivative. The antiderivative of x squared is x cubed. If I were to take the derivative of this, would I get negative 3x squared? No, I need to have that negative. But other than that, we should be good. Okay? Should be good. Okay, let's do this next one. I'm going to write x squared. Normally, what fraction would I put in front of this? 1/2. But what's already there? A 3, so I'm going to make that 3/2. Again, that should not be new, right? We did that last semester. At the end of the semester, so December. And then plus 6x. She's right, it's halves. Okay, so stop being mean. I wasn't asking, I was just asking. Okay. Let's do, there you go. The fundamental theorem of calculus, part 2, to figure out what this is. Okay, thank you. I have heard that one, yes.
It goes like, you better check yourself, you better yourself.
Sure. That's good advice, right? Same with like always brush your teeth. Put on deodorant. Eat breakfast. What other good pieces of advice are out there? Eat your Brussels sprouts.
Mr. Gravy that.
He doesn't eat breakfast?
Yeah, he doesn't.
Here you go. Like I see him in the hallway, I say hello. Is that what you're asking? Are we ready? I'm almost done. This is going to be a lot, so make sure you're focused, okay? It's going to be a lot. 2 cubed is 8, but the opposite of that is negative 8. This is 2 squared, which is 4, but I would not do, you can do 4 times 3 divided by 2. I would do 4 divided by 2 first to get 2, and then 2 times 3 is 6. But if you did 4 times 3 and got 12, divided by 2, you still get 6. All right, that's fine. I just would encourage you to reduce diagonally first, because when you have larger numbers, it's easier that way. 6 times 2 is 12. Hope you're ready for some fractions. Negative 1 cubed, but the opposite of that is 1. This is going to be negative 1 squared, which is a positive 1, times 3/2, which is 3/2, and then minus 6. The left side is a little bit easier, no fractions there. Negative 8 plus 6 is negative 2. Negative 2 plus 12 is 10. Yikes. If I do a little sidebar here. All right, let's get common denominators here. So this is 2/2 plus 3/2 minus, how would I rewrite 6? 12/2. Nice. Yeah, so everyone see what I just did? I just rewriting this over here with same done. Okay? So this would be 2/2 plus 3/2 is 5/2. 5/2 minus 12/2 is negative 7/2. How can I rewrite 10 to have a denominator of 2? 20 over 2 plus 7 halves gives us our answer of 27 halves. I think they will accept decimals, right? 13.5 or 13 and a half. Yeah, decimals.
Are these going to be open response? Are these going to be like the bubbling ones?